is on velocity and other rates of change. All right. All right, so it says in physics. So if some of you have taken physics, some of you haven't, so it's okay if you haven't. Physics is not a prereq for calculus or anything. So it says in physics, some of you have learned that a particle can travel a certain distance from a starting point. This is called the displacement function. So when you travel from the starting point. All right, you're going to have units like meters or feet. When you take the derivative, you're going to find rates of change. Okay, so when I'm coaching cross country and I say go and run 3 miles away and come 3 miles back, so physics people, what would the displacement be at the end? 0, right? It's talking about how much you've moved from the starting point. You've moved 0. So my cross country runners would be really upset if I said, oh, the displacement, you just went 0, right? They would be like, no, I just ran 6 miles. All right, so what's the other word we use for going out and coming back? Distance, right? So the distance you travel is 6 miles, the displacement, so the amount you move from the starting point would be 0. All right, so when you take the derivative, you're actually finding a rate of change. So if you had like meters or feet originally and you take the derivative, right, it's going to be meters per second or feet per second or meters per minute or whatever, miles per hour. So your new units are going to be meters per second, etc. This is going to be velocity. Now think about it. If you take the derivative of that, you add like meters per second, and it's going to be per second. That's going to be meters per second squared. Meters per second squared is going to be acceleration. So you start with position. So that's the s of t. S prime of t is going to be velocity, and s double prime of t is going to be the acceleration. Okay, so s of t is some kind of distance of displacement. Or s of t is some kind of position, I guess. All right, so it says the equation of motion or the displacement of a particle is s equals t cubed minus 3t, where s is in meters and t is in seconds. So find the velocity and acceleration as functions of t. So your velocity is going to be s prime. So I'm going to take the derivative. So we know the shortcut now, so it's going to be 3t squared minus 3. All right, your acceleration is going to be s double prime of t. So you're going to take the derivative of that. So you're going to get 6t. So when I ask you something like find the acceleration after 2 seconds, you look at your acceleration problem and you plug in 2 for your t. So you get acceleration after 2 seconds is 6 times 2, which is 12. So you're just plugging into that function. All right, now originally I was in meters and seconds, so acceleration is going to be meters per second squared. All right, units are very, very important in calculus. If you can think about how something is related to a graph or whatever, using the units, that's going to help you out a lot. All right, next up. Oops. So it says the acceleration when the velocity is equal to 0. Okay, this is a little bit harder. So first we want to know when the velocity is equal to 0. All right, so your velocity function, gotta go back, is going to be 3t squared minus 3. So I want 3t squared minus 3 to equal 0. So 3t squared equals 3, so t squared equals 1, so t equals plus or minus 1. All right, t is in seconds. You can't go back in time in physics yet. I don't know, maybe you can eventually. All right, so we have positive, right? So it's going to be t equals 1. So we want to find the acceleration at that point. So the acceleration at 1 second is going to be 6 times 1, which is 6, so meters per second squared. Okay, obviously they can get a lot harder than this. So I can ask you one where you're going to have to use the quadratic formula to solve for t, and then you use that t value and you plug it into the next one. Do you guys all remember how to store things in your calculator? You might need to do that. So you might need to hit stow to stow the value, to store the value that you have from your quadratic formula. So we'll do that as well. All right, so a cardiac monitor is used to measure the heart rate of a patient after surgery. So it compiles the number of heartbeats after t minutes. When the data in the table is graphed, the slope of the tangent line represents the heart rate in beats per minute, right? So if you're graphing the heartbeats, so you don't have to draw this, but heartbeats and minutes, right? Your slope is going to be heartbeats per minute, right? On top, you're going to have heartbeats for your y values, minutes. So it's going to be a rate. Okay, so it says estimate the value by calculating the slope of a secant line. So we're going to find the slope of the secant line between 36 and 42. All right, so it's going to be at 36, we have 2530. 42, we have 2948 over 36 minus 42. All right, and we calculate it. So let's see who has their calculator out. So Rachel Myers, I'm going to have you calculate this one. All right, Alexi, I'm going to have you calculate the next one. So 38 to 42. So 38 is going to be 2661 minus 42 is 2948. 38 minus 42. All right, and give me the answer to 3 decimal places. So that's common in AP Calc, 3 decimal places. You ready?
Yeah.
Okay.
51 and 2/3.
Okay, so in 2/3, so 0.667, or you could write 69 and 2/3 like that. Or you could write the improper fraction as well. All right, so that's in beats per minute. All right. Yeah. Even, 750. All right, and that's in beats per minute. So if it came out even, you don't actually need that 0. So when it says 3 decimals, you could just do 0.75 since it was even like that. All right. The next one. So 40 and 42. So you do the exact same thing. So between 40 and 42, so 2806, 2948. And you get a value. And then same thing for the last one. For 3080. Okay, so let's see. Kieran, did you get the first one? Okay, over, so, well, no, that's not going to be right. It's kind of high. I bet you forgot parentheses on the bottom. Okay, what else? Anybody else have one? Monica, did you get it?
71.
For C, 71 even?
Yes.
All right, and then D? 66 even? Man, okay, so these are in beats per minute. Okay, so you could do that. You could always find the slope of the secant lines and so on. So it says, what would be a better estimate of the heart rate at exactly 42 minutes? Well, I would probably pick the 42 one and the 44 and the 40 and 42, and then I'd probably average those two things. So I'd get on both sides of it. Okay, so then I would do 71 plus 66 divided by 2, and I'd get that answer. So I take the average around it. Okay, so your AP exam does this a lot where you have to calculate the slope at an exact value. What you could do, so a lot of times they'll say at 43 or something, looking at your original table. So if they say at 43 minutes, right, 43 is right in between those two values. So what would you do to calculate the slope at 43? You'd use 42 and 44, right? And find the slope between them. So that's usually like a part A type question on the free response. So it's like, oh, well, I got this. Just make sure you write the units, because a lot of times you get a point just for having the correct units. Isn't that exciting? So you could totally not know how to do the problem, but you could be like, oh, it's going to be a rate, so it's going to be beats per minute, right? And then you get a point. All right, so it says when you're driving a car, the speed or velocity is constantly changing. So it says there's a definite velocity for each moment, which we have referred to as the instantaneous velocity. So at 2.5 minutes into driving, exactly at 2.5 minutes, I'm going a certain speed. I'm not just going like 0, right? So the average velocity, your average velocity is going to be whatever your S value is, your position, S of B minus S of A, all over B minus A. So that's on a certain interval. But the instantaneous velocity is the slope exactly at that particular point. So it's going to be the derivative of the velocity. Wait. The limiting of the average, sorry, the derivative of the position function. So it's going to be S prime of whatever that point is. A, whatever it is. Okay. So this is just like before, average rate of change. That's going to be average velocity, right? Average rate of change would be velocity. All right. But the instantaneous velocity at that exact second, it's going to be using the derivative. All right, so it says this is very important on the AP test. If they ask for the average rate of change, you need f of b minus f of a all over b minus a. And if they ask for the instantaneous rate of change of f, you need f prime of x, whatever the x value is. All right. So it says if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet t seconds later is given by y equals 40t minus 16t squared. So we'll get to the point later where we can come up with this formula. So we don't always need to be given it. So find the average velocity for the time period beginning when t equals 2 and lasting for 0.5 seconds. Okay, so it's saying average velocity. So when you see that, you're thinking average rate of change. And then you think average rate of change of what? Velocity is the rate of change of position, right? All right, so what we're doing is we're going to do y of 2.5 minus y of 2 divided by 2.5 minus 2. All right, we're just finding the two y values divided by the two x values. Difference. All right, the next one's going to be y of 2.1 minus y of 2. Right, it's lasting 0.1 seconds, 2.1 minus 2. The next one's going to be y of 2.01 minus y of 2, all over 2 minus, or 2.01 minus 2. All right, so Monica, you do A. Who else do I hear clicking away? Ben, you do B. Negative 32. Even? Feet per second. All right, Isaac, do you have your calculator out? Okay, you do C. All right, Ben, what'd you get for B? Ben Lyons, did you get it? No. Ben Vesper, do you have it? I have two Bens. So that works out well. All right, Isaac, what'd you get for C? You know how you can do this faster, guys? Go to your table. Do you guys remember how your table has? You could put in that function and you could do 2.5, 2, 2.1, 2.01. And you'll get it. Yeah, what'd you get? 40. Point. 40 even. Okay. Now, why is yours positive and hers is negative? So I'm guessing we have something wrong. I'm guessing they should both be the same sign. So what's going on? So you're throwing the ball into the air, and it's coming back down. So I'm guessing it should be negative. Was it negative? All right, can you just check C for me? Man, people shouldn't steal my calculator. This is taking a long time.
Negative 25.6.
All right, check C as well. I could just come up with. I think it should be close to negative 16. Is it close to negative? Negative 24.16. Did you guys get that? All right, I think they should all be negative. All right, so it says estimate the instantaneous velocity when t is equal to 2. Okay, so let's do that. So at exactly 2, that means we're taking the derivative, and then we're going to plug in 2, right? So let's just do the derivative with t. So we're going to get derivative of 40t minus 16t squared. So you get 40 minus 32t. So we plug in. So I have y prime of 2 is equal to 40 minus 32 times 2. So 40 minus 64. So negative 24. So it should be negative 24 feet per second at that exact point. So at exactly 2, your velocity is going to be negative 24. You guys see how I got that? Okay. All right, so people are always like, well, why do we have to use the secant lines? Like, why do I have to do that when I can just come up with a slope? This is what I was telling you the other day. So in 1998, the entire test changed. So they used to give you that function. They used to give you what y is equal to. Now they don't. Now they just give you a table, and they ask for what the velocity is at 2 seconds. And they ask for like a estimate, right? So you don't always have the function in front of you where you can just take the derivative. Sometimes you have a graph. Sometimes you have a table. You have to know how to do it without it. All right, so it says in econ, the word marginal is used to indicate a rate. So if you hear marginal cost is the derivative of the cost function. Marginal profit is the derivative of the profit function. Okay, so if you guys are in econ right now, this may be handy. Okay, so nowadays, new efficient machines allow for the cost of the product to not be constant. So for instance, let's say we make a bunch of necklaces by hand. If we make a bunch of necklaces by hand, it's probably going to cost you a certain amount for each necklace, right? Pretty much a fixed amount. But if I buy this fancy machine and have it produce a mass amount of necklaces, right, it's probably not going to be very expensive to produce the 1 millionth necklace as it would to produce the first necklace. Do you guys understand what I'm saying? Why would it be expensive to create the first necklace? You have to buy all that stuff. But once you actually have all the stuff, it's okay. You already have it, right? So your cost may change throughout the problem. Okay, so it just kind of depends on like how much, like if it's worth buying the machine or not. So it says besides marginal cost, you could see many other items about the cost function. So average cost is exactly what you think it is. So average cost is going to be the total cost divided by the number of items you produce, the number of necklaces or whatever. So average cost you'll see as C of X, and then you have a bar over it. So it looks like this, C of X bar. All right, and what that means is your cost divided by X. I don't know why they just don't write cost divided by X. Makes sense. So you'll read that as like C bar or average cost of the function. Oops, sorry, did that make you dizzy? I thought I was erasing. All right, so revenue is the amount of money brought in. So this does not include the cost of purchasing or making items. So your profit, so think about this. If you have like a lemonade stand, that's probably your first thing when you like sold something. Did you guys do that when you were little, lemonade stands? My brother and I love lemonade stands. We'd be like, oh, we just got a quarter. So exciting. All right, so lemonade stands. So your mom or dad goes out and buys lemonade, right? And then you make all the lemonade with your little powder, Kool-Aid. So you make it, and then you sell it. Okay, so you have a little jar, and people put money in the jar. Okay, so inside the jar, that's what you would call revenue. So inside here, that's revenue. All right, but you owe your mom some money. So you're going to pay her back for the lemonade. So let's say she spent a whopping $2 on your lemonade. So you have like 20 bucks in here. And then you owe her $2. Right, that's cost. How much money did you make for the lemonade stand? $18. That's your profit. Okay, so that's your relationship. So your profit is going to be how much you brought in at the end of the day minus how much you spent on it. So revenue minus cost. So profit is revenue minus the cost. All right, so let's do these problems. All right, so it says the cost of producing X units of a certain item is C of X equals 1/4 X squared plus 3X plus 67. The price at which each item will be sold is P of X equals 1/5 times 45 minus X. Okay, notice that's little p, that's the price at which each item is sold. That is not profit. So big P's and little p's matter. So find the marginal cost. So marginal means derivative. Okay, so we're going to take the cost, and we're going to take the derivative. So it's C prime of X. So 1/4 times 2 is 1/2, X to the first plus 3. That's your marginal cost. Find the average cost. So C bar. So C bar is taking your original cost function and dividing by X. So you get 1/4 X plus 3. Oh yeah, that's right. Plus 67 over X. Forgot it. She might already have 5. She's close. She has 4 or 5. All right, so find the revenue. So your revenue is going to be profit minus cost. Okay, so we need the profit equation. So it says the price that we're selling each item is 1/5 times 45 minus X. That's little p.
So it's P of X, big P of X equals 5X.
What did I do? So profit equals revenue minus cost. Yeah, I did the wrong thing. What am I doing? I'm doing that for the next one. Thank you. All right, so revenue. So revenue is the amount we bring in. So your little p is going to be 1/5 times 45 minus X. Okay, so how much revenue do you have? So at the end of the day, how much did you make? That's the price for each item. Yep. So think of it like your lemonade. So if that's your 25 cents that you're making for lemonade, or with inflation, it's probably like $1 that you guys make for lemonade these days. I don't know what you make for lemonade. So let's say you sell each lemonade for $1, and you sold 25 of them. In your little bucket, you have $25, right? That's your revenue. That's what we're doing. So this is the price for each item. So your revenue is going to be the price for each item times the number of items. Price for each times number of items. So your revenue is going to be 1/5 times 45 minus X times X. So I don't know why we write it like that. Let's just go ahead and simplify. So I'm going to have 9 minus 1/5 X times X. So I'm going to have 9X minus 1/5 X squared. That's your revenue. So your marginal revenue will be R prime, right? The derivative, marginal. So it's going to be 9 minus 2/5 X. Do you guys see where I got that? So I took the derivative here. So derivative of 9X is 9. And I have minus 1/5 X squared, so I bring my 2 to the front. 2 times 1/5 is 2/5, X to the first. That's your marginal revenue. Now we have profit. So profit is going to be revenue minus cost. So your revenue you just found. So your revenue is 9X minus 1/5 X squared. And your cost, so I'm going to go back to the cost function, is going to be 1/4 X squared plus 3X plus 67. Is it plus 67? All right, so we get that. Let's simplify a bit. So I have negative 1/5 X squared minus 3, or minus 1/4 X squared. So negative 1/5 minus 1/4. So negative 4 over 20 minus 5 over 20. So negative 9/20. All right, and then I have 9x minus 3x. So don't forget to distribute your negative. So 9x minus 3x is plus 6x. And then I have minus 67. All right, and then marginal profit. So what do you do when you see marginal? Derivative. So we have the profit equation. So p prime of x is going to be negative 9 over 20. Sometimes I do this if I have fractions, times 2x, right? Just pull the number out and then do times 2x, plus 6. So I get negative, let's see, 20 and 2, 1 and 10. So negative 9 over 10, x plus 6. Yeah. Oh my goodness. Part B, 1/4 x plus 3 plus 67 over x.
67 over x. Should do that.
Because your cost function was here. So that was your average cost. So you want just plain cost function.
Is the marginal profit, could you also do like the marginal revenue minus the marginal cost?
Yep, because derivatives will work that way, right? So she said, could you do the marginal revenue minus the marginal cost for profit? You could do that as well. All right, so number 2. So it says, suppose that the cost is 0.02 x squared plus 2x plus 4,000 is the total cost in dollars for a company to produce x units of a certain product. So compute the marginal cost and compare this to the actual cost of producing the 100th unit. So your marginal cost is going to be c prime of x. So you're going to have 0.02 times 2, so 0.04x plus 2. So c prime of 100 is going to be 0.04 times 100 plus 2. So it's going to be 4 plus 2, so you get 6. Okay, so what that is you have some kind of curve, and your cost is in, let's say, dollars, right? So the slope is dollars per item. Okay, so at that point, it's saying the cost for that 100th item. Okay, does that make sense? So it's finding the actual cost, or it's finding the an approximation, actually, for the cost of that 100th item. Now, the actual cost of producing the 100th unit would be the total cost of producing, so cost of 100th unit. This is kind of weird. So if I was finding how much it costs to produce the 100th unit, I'm going to find the total cost of producing 100 items minus the total cost of producing 99 items. Does this make sense? So cost of 100 items minus cost of 99 items. So you can write that out. Cost of producing 100 items minus cost of 99 items. Does that make sense why that would be the exact cost of producing that 100th item? Does that make sense? So you have 100 total items, subtract out 99, you get the 100th item. All right, so the cost of producing 100 items, you go back here and you plug in. So someone put this into their table. So put y1 is equal to 0.02 x squared plus 2x plus 4,000. And then in your table, I want you to put in 100 and put in 99. Nobody's doing it. Ethan, help me out. You did it? What'd you get?
100 right now.
So 4,400.
Yeah. And then the 99, I had 43.94.
Like that. All right, so when you subtract them, you get 5.98. Almost identical, right? 6 and 5.98. They're very, very close. Okay, so it's like, well, why did we learn this whole marginal thing? You could find the cost of producing the 1,000,000th unit by finding the cost of producing 1,000,000 and subtracting out the cost of producing 999,999, right? You guys understand? What was faster? The derivative, right? It was much faster. So when you get these really complex polynomials, it's much faster to use the derivative, which is always 1 degree less if you had a polynomial, right, than your original. So it's faster to use the derivative. So we use marginal cost as an approximation of computing the actual cost. Okay. All right. So it says find the production level that minimizes the average cost. So what does the minimum of a graph look like? How is that related to slope? Okay, so if I had some kind of graph and I want to find the minimum. Yep, you want to find where the tangent line equals 0. Now, in our original thing, we have cost, our cost function. Do you guys see that's a parabola? So there's only going to be one minimum. So we're going to have something like that. So we're going to find when your slope is equal to 0. So when you hear find the maximum or find the minimum, find when slope is equal to 0. All right, so we want to find c prime of x. So we had 0.02x squared plus 2x plus 4,000. That was our cost function. So if I'm finding c prime, that was the 0.04x plus 2, right? All right, so we're finding when it equals 0, so 0.04x plus 2, subtract 2. If I'm doing this without a calculator, I think of that as 4 100ths. So then I multiply by 100 over 4. So negative 200 over 4, so I get negative 50. Is that right? Why is it negative? What did I do wrong here? I have a bad problem, don't I? I changed this problem this year. I must have messed it up. I should have like I'm guessing I should have had this be a negative originally, but it's a plus. So minimizing the average cost doesn't really happen, does it? It would be 0 items would minimize the cost. So it must be really expensive to create these items. So, oh wait, minimizes the average cost. Dang it. So maybe this does work. Average cost. I did this wrong. I tried to minimize the regular cost, right? Sorry. So your average cost, I know. Yeah, so go back to your average cost. Where did I do that? All right, so your average cost was the 0.02x squared plus 2x plus 4,000. You need to divide by x. So 0.02x plus 2 plus 4,000. I'm going to write x to the negative 1 so I can use the power rule. You with me? I thought I had gone over this summer and made sure it worked, so I was really thrown off when I was like, what? It does work? All right, average cost. All right, so c bar prime, I love all these words, equals the derivative. So 0.022, no more x, right? Derivative of 2 is gone, minus 4,000 x to the negative 2. You want to find when that's equal to 0. So 0 equals 0.02 minus 4,000. Because the derivative of 2 is 0. So we took the derivative. All right, over x squared. So we get 4,000 over x squared equals 0.02. And it's just algebra. We're just solving for this equation. So you can multiply your x squared over and divide by 0.02. So 4,000 equals 0.02 x squared. Divide by 0.02. So 4,000 divided by 0.02. So help me out. Go ahead and divide that out. All right, equals x squared. So then take the square root. So x equals what? Okay, so 447.214. So I would say for the one that minimizes the cost, I would say the 447th item, right? Because it's the number of items produced, like lemonades or necklaces or whatever. So the 447th item. On the AP test, they would actually count it correct if you had 447 or 448. So if you had either one. They don't usually do these ones on the AP test, though, the average cost. We don't usually see those. All right. So I'm going to pass out your homework, and then I want to talk about one that's on the homework that's a little bit tricky. Where am I?